recording's on again. Okay, we have 35 in right now. Hello, everyone. Hi, welcome to the demo session with Univ.AI today. We'll be starting session soon in about 5 minutes. We'll just wait for others to join in. There are a lot of people who are joining in right now. And yeah, let's just wait for another 4 more minutes. We still have people joining in. Okay, let's just wait for another 2 more minutes.
Should we start at 7:10 or?
We can start at
Otherwise,
7.
The beep beep of people coming in all the time.
Yeah, Arya switched off that sound, so you won't hear it anymore.
Oh, okay. So maybe we can start in 3-4 minutes then.
Yeah, yeah.
Sounds good.
Is there still a queue, Anusha?
There's no queue, but I'm currently allowing a lot of people to walk in, but there are a lot of people getting admitted at the very moment. But yeah.
It's 7:06. We'll start at 7:10 exact.
Okay. Rahul, we can go ahead and start now. It's 7:10. There's still people joining in. I will let them in, but we can start off with the session.
Okay.
So hello everyone. We have two of our co-founders here, Rahul Dave and Siddharth Das. and let them introduce themselves and Univ.AI, and then we can go ahead with the demo class.
Siddharth, you want to start first?
Sure, I'm sitting in a bit of, I have lamp lighting, unfortunately. Not popular these days, but that's where I'm sitting. Let's see if I can get a little more brightness. Hold on. Yeah, I hope everyone can see me now. I'm Siddharth Das. Okay, this is not good. Hold on. Bulb lights are so ancient. Sorry about that. I actually wasn't planning to speak, so hence sat in a darkish room. But here I am, Siddharth Das, one of the co-founders of Univ.AI. I guess since most of you are here, you've taken the trouble to see the website. Our goals are to provide outstanding data science and machine learning training, leveraging some of the best professors from the best universities around the world, and doing that by providing a very high intervention, high touch process, which means you learn live from professors and that you have lots and lots of mentorship time where you problem solve, do homeworks, labs with your mentors live, right? And we do a lot of other things. We do research, we do consulting, we provide the kind of placement assistance you can only achieve at, again, prestigious institutions. And so all in all, that's our goal, that for people who study with us, work with us, we want to be and intend to be an alternative to some of the prestigious universities around the world. So that being our goal, I'll let Rahul take over from here.
Thanks, Siddharth. Hi, everybody. I'm Rahul. I used to be a lecturer at Harvard, and I joined up with Siddharth to start Univ.AI because for many reasons, but which I'll come to in a little bit, but mostly because it's kind of fun. So what I would like to talk a little bit about is what we're going to talk about today, and a little bit about our courses as well. So let me just start by saying we're a somewhat small bunch of people, but extremely motivated bunch of professors, students, software developers, and we've come up with what we think is one of the best systems to teach. We'll talk a little bit more about that. And today's example is one of visualization. This is absolutely critical stuff, whether you are doing any kind of science or whether you're doing any kind of communication with your boss or whatsoever. So I hope that what you will learn today will actually be somewhat useful to you. A little bit about myself. I started out at Campion School in Bombay, went off to Ruparel College after that, which is in Matunga in Bombay. Went off to IIT Kharagpur for a while, hated it, and decided to come back to Bombay and go off to St. Xavier's College. That turned out to be fortuitously, and I say fortuitously because sometimes you need luck in life, and I think I had it at that point. Got to work with the person I wanted to work with for my PhD in cosmology at the University of Pennsylvania. That was Paul Steinhardt. He's one of the guys who did inflation theory. From there on, went off to do solar system astronomy. And it was in that process that I got into a lot of AI and machine learning, simply because of the improvement in the CMOS chips and the CCD chips, which you now see in each one of your little cell phones, but back in those days used to be in the increasing number of cheap SLRs that used to come on the market. And this, of course, affected us in astronomy as well. And we went from being able to take maybe about a gigabyte of data a night to about, at this point, multiple terabytes of data per night. And I think you'll realize that if you have multiple terabytes of data per night, you can't do anything by hand to analyze this. So you need automated pipelines. And those pipelines use machine learning to figure out whether you saw something interesting or whether it was just another one of Elon Musk's satellites going past you. So that's sort of like, you know, my journey into this subject. And so I went from Penn to Harvard to do some of this astronomy stuff, and then I stayed there as a lecturer. And then finally last year we started Univ.AI. So that's sort of my journey. As we go on later today, I'll tell you a little bit more about our company and the kind of stuff we do. But let me actually get to the subject itself. So let me get my slides going and share my screen. It would be great if I, kind of stupid if I didn't actually share my screen. Okay, and let me just make sure everything is in the right mode here. Okay, so if I've done this right, then you should be seeing a slide, a rather white slide with a kind of purplish Univ.AI and visualization with my name under it. If anybody's not seeing this, please let me know so we can actually figure out if things are wrong.
No, Rahul, we can see it.
Yeah, you can see it? Okay, that's good. Okay. So give me a second and let me just get going. I'm just trying to get my Zoom thing. Yeah, I'm actually stopping the share for a second because Zoom is kind of weird in the way it arranges things. I want to move something on the other screen so it doesn't come in my way. Okay, let's share the screen again. And share this. Then we go Zoom. Once again, okay?
Yep.
Yeah, okay. All right. So visualization. You know, it seems, and in a lot of data science courses, it's actually given a short shrift as compared to, you know, the more sort of like machine learning things like logistic regression or decision theory or any one of those things, all of which we cover really well in our courses. But visualization is probably one of the most important things. And honestly, if somebody gave me a machine learning model, you know, and I've done this both as a person who's consulted with oil companies and healthcare companies, as well as a professor. If somebody gave me a model in which they showed me the results, but didn't show me the visualization of the results, that either failed their exam or I'd ask them to stop working with me. Very simply because if you don't understand what's going on, and you can only really understand what's going on really well by doing some kind of visualization, you really don't know what you're talking about. And it's important in this business to know what you're talking about. So just to reiterate a little bit, who's Univ.AI? It's a bunch of crazy people who love to learn and teach stats and AI. It's a kick-ass learning platform. I'll show it to you a little bit later, the likes of which I don't think has been seen before. It's learning by doing, and this is really important, both math and code. So it's quite application-oriented. In fact, each week we give you a homework which will make you scratch your head a little bit and give you a little bit of pain, but out of that pain comes great gain. And at the end of it all, you have a chance to do research at companies. We do a lot of consulting, and if you're good, we'd love for you to join us. Or, you know, do it somewhere else where, you know, you'll have fun. Or, you know, go to a good university and do research over that. And so you have both opportunities with us. Today, we're going to talk about Viz, visualization, and I'll keep calling it Viz from this point onwards because I know I will mispronounce visualization about 15 to 20 times. Why Viz? We want to be able to communicate what we have been studying. We want to be able to explore stuff properly. We want to be able to answer questions. How can we do effective visualization? There are 4 principles we'll talk about. Graphical integrity, keep it simple, choose the right display, choose the right kind of graphics that you want, and make use of color effectively. So this is actually a lecture, part of a lecture. We've sort of taken out a lot of the Python stuff and so on and so forth from that lecture because we don't know the backgrounds of everybody. So we thought we'll keep it at a more or less, you're a smart person, we're smart people, let's have a conversation level. And we do have a little bit of exercises at the end. Oh, somebody is writing across the screen. Hey, visualization, good idea. Part of our data science, this is part of our data science 1 course. And so we'll teach you how to do this in that course. And we'll show you our platform as well, and we'll show you some of the plotting stuff. In fact, the window I have open is to show you the plotting stuff that we taught. We just finished a course. That course was rather strangely called Know This First, which is a rather strange name for a course, but it kind of actually described the course. We took you there from not knowing any Python whatsoever to writing your own deep learning library, which I don't think any course so far has ever tried to do. Some of the students from that course are around today as well. So you may want to, when you split into breakout rooms, try and find them, talk with them, or afterwards we'll hang around a bit, and we can all talk about it if you want. If you want. Okay. So without much ado, let's get to the main action over here. Whenever you are doing data science, or for that matter, any science, or for that matter, any real kind of activity of any worth, you're usually starting by asking an interesting question. So why are there less deaths reported in India than there actually are from COVID-19? That's an interesting question. To sort of answer this question, you're like, okay, I'm going to go get some data. That's not so easy because the government of India is kind of bad about putting out data. But there's a great site called COVID19India.org, which is doing a much better job if you want to go look. So you get the data. Then you might spend some time exploring the data, seeing the trends in the data, seeing where at some points stuff has there's some strange spikes, there are some strange increase in deaths, there are some strange classifications. Like at some point, Ahmedabad changed from classifying deaths due to comorbidities as COVID deaths to not classifying those to look better, but that changes what your data is showing you. So you got to explore the data. So in exploring this data, you're going to do some stuff. One of the first things you're going to do is to do this visualization. And when you do this visualization, the first thing you're going to do is look at it and say, oh my God, what happened at that particular point? Something interesting happened. And you'll see some examples of this. After that, you'll build some kind of a predictive model. And in that predictive model, you'll say, well, let's see, is the peak in India going to be today? No, we still haven't reached the peak. Is it going to be tomorrow? Probably not. And you'll make some kind of prediction and you'll go forward, right? So that's what you'll do. Then you'll finally communicate and visualize the results. And at that point, somebody from the CBI will contact you. Why are you doing this? No, I'm just kidding. But my point is that it's like a detector process, right? It's like you do all of these things and then you get some new data from somewhere else. So you triangulate with new data. You say, oh, okay, the fatality rate in Italy was something else. It's something different here. What's going on? Let's go and ask another interesting question. Why are there less people dying in India than that died in Italy? And then we come up with a model for that. And then you keep asking these questions and you keep asking and you keep coming up with stuff with it. But in all of it, you need to do some visualization to try and figure it out. And there are two main places where you need to do this visualization. One place is where you're actually just looking at the data. You've got this data fresh out of the oven and you want to see what's happening in it. The other place is that you've come up with a model. You made some kind of prediction, or you've come up with some kind of way to show this data and you want to communicate to some stakeholder, maybe on Twitter, or maybe to your boss, or maybe to the prime minister. What's going on over here? Let's try and figure it out, right? So that's where visualization is kind of important. So speaking of COVID, this is why I was saying we still haven't quite got to the peak. We're still going up and going up and going up and going up and going up. So this is your kind of communication piece. So this is a very nice graphic from the Financial Times. You may have seen this graphic before. And what it does is that it says the number of days since the first time you had an average of 3 daily deaths. And that's why you'll see, for example, that China, which is on the bottom right of the screen, it's been a long time since they started their problems. But, everybody's now been in it for a long time. The US is somewhat before Brazil, which is somewhat before India. We're kind of later. You see Pakistan doing a much better job at this particular moment. And you see Germany doing a much better job and having these kind of, though unfortunately having some of these undulations. And you see the US and India and Brazil, three big democracies, not doing that well at this particular moment. Okay, so that's a communication. What's the point of this communication? Well, that's up to you, right? If you're writing an article, democracies can't handle COVID well, this graph might help you. If you're writing, but you got to be careful of the counterfactuals. Large countries don't handle COVID well. This graph might help you with that as well. Can you distinguish the two by this graph? Probably not, but you're communicating something from it. So that's one thing. Here's another example of this sort of communication. So this is the trilogy meter. This kind of plot is what's called a small multiples plot. And you're plotting the same thing. Now here, the sequels, Star Wars 1, Star Wars 2, Star Wars 3, and how good were they as rated by a bunch of people. And so you can see, for example, that Star Wars, Indiana Jones, all very nice, all of the sequels, according to people. Matrix, third movie, not so good. Planet of the Apes, third movie, not so good. Terminator, even though Arnold was in it, third movie, not so good. So on and so forth. I like any movie in which Arnold is there for, because I think he's a cool guy. But so I might give you a different answer. But this is what most people thought. So this is another sort of communication, right? This is kind of fun. More fun than that at any rate. But the other big use for, and this is probably the more important use for most people, is to do exploration. So on the upper left corner over here is the output of a logistic regression model. And this is showing the probabilities based on certain characteristics of people that they are male or female. The blues being males over here and the reds being females. And the lines are telling you how likely things are. Logistic regression gives you probability models which are straight lines. And so you see over here, yeah, that may be the 0.1 probability line over there. So, we have some nice, let me actually get the annotation toolbar going as well. And clear all drawings. There we go. Return it to its pristine form. The bottom right corner is one in which we have over here movies from the IMDb, ratings of movies from the IMDb as compared to the average rating. And so this is a score between 1 and 10 that you can see on this. And the gray thing over here is the overall rating of movies. So most of the movies were rated, I think, say around 7. So most people thought that most movies are decent. And you look at adult movies, they're rated kind of worse. Adventure movies are almost on top. Biography movies are kind of rated better than average, as you can see from this graph, because the red stuff is to the right of the gray stuff. Film noir movies are rated way better than average. They're like only between 7 and 10 as compared to the gray stuff. But you see there's much less of them. Not too many directors make film noir movies, like LA Confidential and other such movies, because not the easiest movies to make, right? And so this is your kind of exploration to sort of figure this out. Why might you do this kind of exploration? You might be trying to write a recommendation system for which movie a person should see. So this is one kind of exploration where you're seeing the outputs of your models. I'm not able to move my slides. Just give me a second. I'll fix this. Oh, because I'm in the annotation toolbar. Okay. Okay. Moving on. So the other reason you might want to do is to actually debug your algorithms. The algorithm in the upper right corner is a algorithm that's often used in deep learning. It's called stochastic gradient descent. And in stochastic gradient descent, you are going down something called a loss surface, and you're trying to find the minimum of this loss surface so that you can find a good neural network. And that's what's happening on this right side. And you can see that it has the little squiggliness, the red squiggliness that a stochastic gradient descent algorithm has. And on the left side over here is an example of an algorithm called Hamiltonian Monte Carlo, where the green dots over here are what I call divergences. And these divergences are places where your algorithm basically blows up. All your results go off to infinity, and they're not good things in any algorithm to happen. So that's someplace where the algorithm's gone particularly bad. And you can see there's a bunch of them which is clustered all over the place, and some of them which are clustered at the bottom. And that's sort of telling me that in this thing on the y-axis called log of tau, I'm not able to get deep enough for some reason or the other. And I need to do something to fix my algorithm. So these are kind of the reasons you might want to do visualization. Here's another reason why you might want to do visualization. So here's a scatter plot of things on the x-axis and things on the y-axis. What does this look like? So just feel free to unmute yourself, answer, and then mute yourself back up, right? We'll keep this this policy and go on. So what does this look like to you?
A dinosaur.
It's a dinosaur, right? But it's also data with an x mean of 54.26, which is somewhere around here, and a y mean of 47.83, which is somewhere around here, which you can see, this is roughly the mean of all of this data over here. It also has the same standard deviation. There's 16. Standard deviation, roughly speaking, that's the width in both directions. So 16 in this direction and 16 in this direction, and 26 in this direction and 26 in this direction, which kind of makes sense when you see this dinosaur. Okay, now, watch this. This is going to be an animation here. All these data sets have the same x mean, the same y mean, the same x standard deviation, and the same y standard deviation. Kind of wild, huh? Star, dinosaur, X, all of these sort of things. So if I had just given you these numbers that you see on the right side over here, would you have been able to tell me much more about this data set, or would you have even realized that there's such a diversity of data sets that give the same number?
Nope.
No, right? Yeah, so this is kind of the point over here. Without visualization, you'd have been kind of sunk as to understanding what's going on. So let's take another example, and we'll come back to this example at the end of this class. This example is actually an example with almost a 30 to 40-year-old history, and things happen in the 40 years. So Will Burden did a survey in 1951 on antibiotics and drugs to deal with antibiotics. So here's your data. It has a whole bunch of bacteria on the first column, and so these are your bacteria, the antibiotics on the second column, and the gram staining, whether it stains purple or whether it stains pink when you put some kind of chemical in it. And these numbers are what are the minimum inhibitory concentration, or how much of the antibiotic must you take before you kill these bacteria. So what number is better over here, less or high?
Less.
Less, right? Exactly. So less of this, the better. So there you go. So if you got, so, you know, something like 0.001 as compared to 1, super good. So it looks like penicillin might be kind of good for Brucella anthracis, for example. So let me ask you, what questions might you ask? So once again, just answer and then mute yourself back.
Which is the least amount? I mean, which one has the least amount I can take? That one is the better.
That's right.
Best.
So so you're saying let's go in this horizontal direction, right? Let's say Diplococcus pneumoniae, right? Which is the least amount I can take, which will cure me. And it looks like penicillin is the way to go for that particular one. Good. What other questions might you ask?
What unit are we measuring here?
This is in, let me just give you, I think I wrote it down. I can never remember these things off the top of my head. Milliliters per gram. So if I have a gram of bacteria, how many milliliters will kill it?
Is there a antibiotic that kills all or major bacteria or viruses?
That's right. Is any one of these antibiotics doing the best job on most of these, right? That might be the best broad spectrum antibiotic you give. That's a very good question. Good answer there. Any other questions?
Maybe on what not to choose from the medicine antibiotic. So if there is a bacteria which is not killing it, so we can take that out.
Yeah. Which one, what not to choose? Good one. Any other ideas?
Maybe which is the most effective and which is the most ineffective.
Most effective and most ineffective, very good. Can I do some kind of clustering of these things?
Like what is the target? What is the kind of audience that what is the kind of patients that some drug is more effective on
Exactly, right? So I mean, for example, I see these 3 streptococcuses at the bottom of this table, right? Are those streptococcuses being particularly attacked by any one of these antibiotics? If you look at Streptococcus faecalis, you might say no. But if you look at the other 2 streptococcuses, you might think that penicillin is a much better drug, right? For example, does that make sense?
Yep.
You should also answer yes or no at any given point. And if it doesn't make sense, just tell me straight. It
Can we
doesn't
check
make
the
sense.
combination of the antibiotics which is affecting in the bacteria, or if this is affecting, that is minimizing its effect?
Very good. Yeah. What kind of combinations might you take? I don't think they have the data in this particular thing, but that's a very good question. Yeah. So these are some of the questions you might ask just by seeing this data, right? So we can try and answer some of these, and you'll answer some of these at the end today. But here is an example of these are the gram positives and these are the gram negatives. This is a rather interesting graph. Will Burton came up with it in 1951, and Mike Bostock, who does Observable HQ now, but was the head of the New York Times visualization team, came up with this one. And it's got a very interesting design. And so design is kind of important. So this is a very interesting field, visualization, because your artistic skills are also actually really important over here. So if you look at this wheel and you'll go with increasing radiuses, you'll see that unusually the minimum concentration has been put towards the outside. You can see it's 10 to the minus 3 on the outside and 10 to the 2 all the way inside, right? 0.001 and 100. So in this case, bigger bars are better. So can you make any conclusions from this? Let's talk about gram-positive bacteria, those which are doing, these kind of purple stains. Which seems to be the better antibiotic for these?
Penicillin.
Neomycin.
Penicillin, and then, neomycin in some cases and penicillin in some other cases, right? And how about for gram-negative ones?
Neomycin only.
Pretty much neomycin only, right? I mean, penicillin is kind of no good for that. How effective are these drugs, right? If bacteria is gram-positive, then penicillin and neomycin are the most effective. But if it's gram-negative, then neomycin seems to be the most effective. So that's something they kind of came up with based on the staining. And this thing has predictive value, right? So they said, okay, let's go and look at other bacteria, right? And maybe we don't know that much about these bacteria, but to 0th order, we know that antibiotics kill bacteria, and we're going to give you penicillin and neomycin if that bacteria gives you a gram-positive stain. So useful, really simple visualization, but kind of useful. Okay, but there is a backstory to these, and that backstory you are going to be the detective to figure out. We'll come back to that in a little bit. Okay, so let's get to some of the main part of this lecture today. And the main part of today's class is about effective visualization. What are the principles of effective visualization? And hopefully after you're through with this today, you'll be able to keep some of these things in mind and be able to figure out how to do some of these things. So don't worry about the exact details of how you're going to do these plots, because that depends upon the software you use, whether you're using R or whether you're using Python or whether you're using Tableau. Tableau, by the way, has a public edition, which is really, really nice, and I strongly recommend it. But these are the basic principles, and it's important to get the principles right, okay? So the first principle is to have graphical integrity, which means be truthful in what you're doing.
Laptop.
Okay. So you have graphical integrity. Then the second thing to do is to keep it simple. The moment you make it not so simple, your marketing team will become extremely happy, but you and your boss will be extremely unhappy. I'll give you examples. Third one is to use the right display, the right kind of plots for the right kind of data. Why did Burton come up with this, right? For example, that's the kind of question you're trying to answer there. So that's using the right display. And the fourth thing is the sensible use of color, because you can totally muck up the use of color. And we'll talk about that. So let's go to the first thing. So this part of the class is going to be extremely interactive, okay? So what I want you to do is at any point, when I ask a question, unmute yourself, answer the question, and then mute yourself back. And please, everybody participate, all right? It's not going to be that much fun if only 2 or 3 people participate all the time. It's perfectly okay to get stuff wrong. Just so you know, for example, I don't think I've ever got a C program to ever compile on the first go. And I'm actually really good at writing code. So you know, we all have some things which we need to work on, like getting C programs to compile. So don't feel that if you're getting something wrong, that's a bad thing. That's actually a good thing, because that's how you're going to learn more. Okay. Yeah, I learn much more from the C programs that don't compile than those that do. Let me make that part extremely clear as well. Okay. Have graphical integrity. Let's talk about this. Okay. What is wrong in this plot? So this came on August 7th. It came across my Twitter. As an Indian woman, I can confirm that too much of my time is spent hiding behind a rock, praying that the terrifying gang of international giant ladies and the Latvian general don't find me. So you see this Latvian woman out there, looks big, and it looks about to crush the Indian woman who's at the bottom right. What's wrong in this plot?
The scale is completely wrong. Like this 5 inches is so big, and that 5 feet, it started very low.
Exactly, right? It's starting at maybe 4 feet, like 4 feet 11 inches or something of that sort. And so the Indian woman is 5 feet tall, and the Latvian woman is 5 feet 5 inches tall. That's 5 inches out of 60 feet. That's 1/12, or something of the order of 8%. Does the size of the Indian woman versus the size of the Latvian woman look like an 8% change to you?
No, it's the scale is completely wrong.
It's completely wrong, right? It's like 300%, right? It's like 3 times as big. Yeah, exactly. So that's what's wrong. So this is the kind of stuff that you don't want to do when you make a plot. By the way, this is the kind of stuff that that lots of lots of shady news outlets do a lot of. So, for example, Fox News will in the U.S. will do a plot saying, Trump made these tax cuts. How much did they change people's wealth by? And then they'll start it at like 100,000 instead of at 0. Okay. And then the change will look very big. So things like that. Okay. What's wrong in this plot? This is from Georgia, which is a state in the US, and it's the number of COVID cases over time.
Start date maybe, like it's taken from 28 April 2020.
Yeah, but what's the next date?
Yeah, it's not sequential.
Yeah, it is not sequential actually.
It's not sequential. Is it going down? Is the amount of COVID going down in this non-sequential fashion?
Not exactly.
Pardon me?
Not exactly. Like in the first part, there's 28th of April, then shifts to 27th. And then you see 4th of May, then 6th of May, and suddenly 5th of May.
Yeah, so it's all messed up, right?
Yeah, it's messed up.
The interval is messed up.
Yeah, it's completely messed up. What do you think they were trying to do with this plot? I mean, they literally put this plot out.
They're trying to show it's decreasing.
Trying to
Misguide us?
Yeah.
Misguide into thinking that the cases are decreasing with the dates.
Yeah, exactly. It's because they wanted to open everything up. Because Trump was trying to push everybody to open stuff up. So they were trying to do that. Now, if I actually plot it correctly.
The graph visualization is wrong. It should be a line graph which will indicate the trend.
Yeah, right.
Yeah.
It should be a line graph.
Good point. Actually, good point. This is not the ideal thing. I think what they wanted to do was to show the 4 counties, but you're absolutely right. They could have shown 4 lines instead to show the trend. But you can see that, the trend is a little bit more, mixed up over here when you look at it in the correct graph. So this is the kind of stuff you need to have, you need to plot stuff with a degree of integrity, and it's sort of like answering the question, what exactly are you trying to show? Show people with this graph. And here, if you're trying to show what the case is, as one of you made the point, maybe a line graph would have been better. And then don't do this. Or if you want to do this, for crying out loud, don't do it so badly. Okay? If you want to do a sleight of hand, at least be better at it than this. This is just poor. I mean, who do they think they would exactly fool? So, yeah. Okay, so the second thing is to be proportional. You need to be a bit careful about how you plot stuff. So this was, after the last American election, this was a graph that was plotted somewhere in the West Wing. So if you look at this graph, what is the first thing that jumps out at you?
The color red?
The color red, right? So what do you think? So the color red in the US usually means Republican and the color blue means Democratic.
So it means
Doesn't
that
align with the states.
No, it is definitely aligned with the states, no doubt about that. But if you saw this, if you didn't know anything about elections in the US,
It shows that the concentration of the voters or the elections in that region,
There are no legends.
But what would you think if you saw this graph?
There are no legends.
Majority of counties voted for Republican Party.
Exactly.
Max sense, right?
Voted for, yeah, majority of the
Indicates
US voted.
Maybe there are only three parties, and like which countries are having this?
probability of winning.
no. I think it shows that one party has swept the elections across United States.
Yeah, that one party swept it, right? It totally looks like that. That one party has swept it, and the Democrats were routed in this election. That's what it kind of looks like. Now, you know the outcome of this past election. Yes, the Democrats lost the election, but they did not actually lose the popular vote in the election. In fact, they won the popular vote by 3 million votes. Now, what is the problem in this graph? Why do you think that this is not an honest way?
Misrepresentation of the minority, or maybe their democratic thing.
No, I mean, at some level, you can make the argument that, as someone pointed out, that this is just coloring the counties.
Yeah.
Is it like the color is not proportion to the number of the Democrats of the Republic there?
the percentage.
We
percentage
can't
color is
understand
not-
how many people are there. Like in a big area, maybe few number of people are there, so that doesn't count as like winning.
So it does not weighted by the population of a county, right? It does not weight by the population of the county. It just colors the county red, right? So here are some ways you might change that. So this graph on the upper left is just the previous graph, except that each and every county's boundaries have been sort of drawn on it, right? Over here. Okay. Fair enough. I'm actually wondering why Washington, Utah, and Maine don't have proper colors, but that must have been some kind of problem. But if you look at the graph on the upper right corner over here, so this is actually taking each county and then it's putting a circle in that county, which corresponds to the population over there. And now you see that this may actually make much more sense to you, because you're seeing that these circles are big. And if you take the complete area of these circles, which is not still the best graph because it's hard for me to add the areas of these circles, but there is some chance that the areas of these circles are actually greater when you add all the blue than when you add all the red. The bottom left corner is something called a cartogram. And that basically deforms the size of each county as compared to its population. And so now you can see a little bit more clear, the blue things as compared to the red things. But these are complicated maps to sort of make these cartograms. The fourth one out here is another way to sort of like talk about this, which is to weigh the state by the population instead of the county by the population. So you can see over here, like New York State and California State and Texas State have huge populations. And so they get much larger, red areas. And just to be kind of nice, they have actually kind of drawn it in the shape of a faux-looking United States, right? But it gives you some idea, at least geographically, where all the Democratic votes are from. You can see in the Northeast, which is highly populated. There's a lot of stuff. You can see it in the graph on the upper right as well. But each one of these graphs, not including the upper left, is a little bit more kind of honest about how the weighting of these graphs is. And the bottom right actually perhaps tells you the whole story. It tells you that Trump won 304 electoral votes because of the US's weird system in which all the electoral votes in a particular state go to a particular party, if you want it, no matter, versus what the popular vote looked like, which is what is shown by the map over there. So this is at some level a much, much more honest kind of representation of what happened in the election, and tells you Trump still won, but why? Okay. So the next thing is to include uncertainty in your graph. So what have we talked about so far? Be proportional, be honest. And the next thing is include uncertainty, because no measurement we ever make has one number. It's got one number plus or minus something. There's always error bars on stuff. And here is a really good example. So this is how, and this is the same thing with the Indian Met Department as well. This is how the US Met Department indicates how a cyclone is progressing. Okay. Now, here is a example from Alberto Cairo at the University of Miami, whose website you should go to, and if you're at all interested in this stuff, follow him on Twitter. He's really good. And he created this graph to show to ask the following question, and I'm going to ask the same question to you. Here's a graph of a hypothetical hurricane Cairo, category 5, which means the fastest, the worst kind of hurricane, about to hit New Orleans. It's kind of taking the same path that Katrina did, and asking the question: when you see this graph, what do you think is happening? What does that circle, which is around New Orleans, mean to you? So maybe
damage would be more.
The damage will be more where?
At 8 p.m. Tuesday.
You feel that the damage will be more at 8 p.m. Tuesday. Okay. Well, what else?
It's spreading. It's spreading. The whole spread is actually
The
increasing.
New Orleans is the center of the origin of that, and it will be moving to 8 p.m. Saturday to Cuba. So New Orleans is the hotspot. So.
It's the hotspot. Okay. So it's
that is where the landfall happens.
Pardon me? Could you say that again, please?
The landfall happens at New Orleans.
The landfall happens in New Orleans, yeah. Just very close by to it, yeah. Any other ideas as to what this might be telling us?
Actually, according to me, it's like the path of the cyclone is being traced from at the same time, like 8 p.m. and wherever it will land. But the bigger circle, like the translucent one, is having room for error. But maybe if it does not follow that path.
That's where it could go? Is that what you're saying? If it doesn't follow the blue path, it could go anywhere inside that circle. Is that sort of your idea?
Yeah, that's what I think.
Okay.
So it can also establish the boundaries of danger zone.
It can also establish the boundaries of danger zone. Okay, so this is what this visualization is conveying to you guys, right? Okay. Now, what if I told you out of all the answers you gave me, the only answer that was correct is that the highest impact is supposed to be around New Orleans? I think the point that you would say is that this is actually a really bad visualization from that perspective, right? So let me explain what actually is happening over here. So this is what's actually the meaning of this. So I think there's one person who said that this is the uncertainty at Tuesday. And this kind of makes sense, right? It's 8 p.m. Saturday. The orange dot is telling you where the hurricane is right now. So you know where it is right now. So you have a lot of certainty down there. But as you're trying to project out from Saturday, Sunday, Monday, and Tuesday, your uncertainty is going to become larger. So the person who said, that this is sort of like the uncertainty envelope of where this is going to go was actually correct when they said that. It is not the size of the hurricane. But most people who see this kind of a graph actually think it's the size of the hurricane. And I'll be extremely honest to you, that's what I thought it was too, that it was the size of the hurricane. But even that uncertainty is not exactly correct. What this is, it's basically telling you where 66% of the probability of the hurricane going is. So the cumulative probability of that the hurricane will strike between the left point over here, which is east of Galveston, and the right point out here, which is left of Pensacola, is 66%. That it's going to strike the coastline somewhere between there. But what is that leaving out?
The other 1/3 part.
The other 1/3 part, that a city like Galveston or Houston or Corpus Christi or Pensacola or even St. Petersburg has a chance of the hurricane hitting it. And so this graph actually gives you a very, very bad idea, because it makes you think that, okay, there's 66% probability that it's going to hit between these two, but 33% is a huge probability that it's going to hit outside of these, that this hurricane could just veer off and go and hit Pensacola or go and hit Corpus Christi instead. Totally possible. So this is actually a really bad visualization used by almost all med departments all over the world. So this is what Alberto Cairo suggests. Said, well, show all the probabilities. Yes, the highest probability is to go around New Orleans. And as you go, it's lower under Biloxi, lower to Mobile, but there is still some probability of going east of Pensacola and still some probability of going just a little bit east of Corpus Christi. And maybe you could do an even better job by writing the probability, what levels of probability are to go to those places. So it's not easy, right? I mean, to design a good uncertainty visualization, but it's important because otherwise people get the wrong idea. Okay, so that's our first part, right? And what were the things we talked about in this first part? We talked about looking at uncertainty. We talked about being proportional, and we talked about being honest. Okay, so that's the first part of this. Let's go to the second part of it. Second. Okay. Second part of it is to keep it simple. Okay. What do I mean by keep it simple? So, look at this plot. It's a bar chart, and it's a bar chart of the miles per gallon that various cars give me. So I'd like you guys to criticize this plot and tell me, what do you think is not so good about this plot? Just look at it and, sort of like almost like intuitively, almost, from your gut. What do you not like about this plot?
Not sorted.
It's not sorted. Very good. Doesn't help you see which one is faster than the other. Your eyes got to go all over the place. Very good. What else?
The x-axis on the
What
right.
does it imply, the x-axis?
What does the x-axis imply? Exactly. What does the x-axis imply? Is it miles per gallon? Is it miles per meter? What on earth is it?
And why they did this plot, like bar charts have a specific reason why we do it, but here we are not able to understand that. Is it for comparison or it's for quantitative analysis? What is it for?
Yeah, what is it for? Okay. What else?
It doesn't give information about their engine, like if it is a 400cc engine or 10,000.
Absolutely, it's missing out engine about, yeah, it's totally missing out information about the engines. This data set is, so we're actually going to provide you 3 notebooks in Python, Jupyter notebooks, and you'll actually get the entire data set and you can play with it, with the miles per gallon, the number of cylinders, and all of these things. That's a very good point. Okay, so now go off the more substantial things and become become an art teacher and tell me what do you not like artistically about this plot?
It's only in single color.
Color code. They could have used different colors.
We could use different colors, but can somebody counter criticize that?
The number of colors should match should be less, and if the cardinality, if the cardinality is too much comparison, too much.
If it is in a vertical, also it would be better. Like, rather than
okay, we might want to put it vertical. Okay, what else?
The box is not necessary.
Exactly, the box is not necessary. So let's look at some of these things. So, and this is an example I've actually worked out for you, which you can look at your leisure. So the first thing I do is, in 1 is the plot you saw previously. In 2, I take out some of the spines. I take out the upper spine and I take out the right side spine. Okay. And the next thing I do is I actually put a grid with these numbers over here. I still haven't done the miles per gallon, but I put a grid, which makes it easier to read off these things, right? What is 5 miles per gallon? What is 10 miles per gallon? What is 15 miles per gallon? I'll tell you it's miles per gallon so that you know over there. Okay. Okay, good point. Look what's happening in 3. I've actually gotten rid of all the spines because I didn't need any of the spines out there. And these grid lines, this 5 miles per hour grid line, 10 miles per hour grid line, which is white in color, going vertically actually helps me understand this a little bit. Look at number 4. In 4, I've even gotten rid of the x-axis numbers because, and what I've done is I've actually made things a little bit shorter. So you can see in graph number 3, Where I'm at 30 miles per gallon, I've gone, 1, 2, 3, 4, 5, 6 of those. So I can actually read them off. But here I made it a little easier, and I made these grid lines every 10. So with the Honda, you can read off 10, 10, 10, and 100.
Yeah.
Do mute yourself, folks. So I'm cleaning. But by the time I've come to 4, there are still 2 major problems that look out at me. Can you tell me what those are?
There are so many lines. It's like still so many lines.
Okay, still too many lines. Maybe the spacing is off. It should be a little bit more open, right? Do you see something weird below Pontiac on the Merc?
The precision. Merck has too many digits after the decimal point, while others have just 1 or 2 digits after them.
That's right. I mean, is anything more than 1 digit or 2 digits even needed? Even 2 digits may be too much, right? Who thinks about second decimal digit precision in miles per gallon? You could even probably get away by not having any decimals. What else is missing?
Yeah, there are too many data points out there. Probably we can split the graph into 2, saying top 5 and bottom 5.
You could do that, yeah.
Absolutely. There's no leveling per miles per gallon.
Miles per gallon is not written. Yeah. So okay. So you guys have got the kind of the criticisms. So that is a process, right? Almost always you will create the one graph first, because that's actually very easy to create by default in any kind of programming language or library, right? Very easy to create in Python, very easy to create in R, and then you have to do some work cleaning it. You will almost never give your professor 1 or your boss 1. You'll want to give your professor or boss 4. So kind of important. Don't do this, even if your marketing department insists on it, because you can do this directly in Excel. Don't. If I ever saw this, I will personally come after you with a lathi. So just don't do it. If for no other reason than for that particular reason. The 3D thing adds absolutely nothing to any of these plots. Maybe the bars on the bottom right, which are showing the 60 to 80, add a little bit, but beyond that, nothing else. The skyscraper plot on the upper left doesn't do anything. And definitely the bananas on the export of bananas in the bottom left do not add absolutely anything. Okay. So the third thing is to use the right kind of graph. This is really kind of important, that you use the right kind of graph to do things. I'll let you, I'll put this link up so that you can actually go to it. These kind of chart suggestions. This gives you some kind of idea on how to decide which graph to use for what. It's really kind of useful. But let's actually just think through this a little bit. Okay. So look at the top graph and look at the bottom graph. In the top panel, right, the female male heights in inches, which graph do you think is more appropriate?
The one on the left.
The one on the left. Why?
Female and male are 2 distinct things. Like
exactly, right? Unless you are terribly sexist and want to say that male greater than female, there is no ordering of male and female over here. So the graph on the left makes sense. How about at the bottom?
The right one.
Oh, whether they are female or male, 10-year-old or 12-year-old.
No, so we don't know whether they are female or male, right? On the bottom, they're just, this is a different graph. 10-year-olds and 12-year-olds. So somebody said the right graph, and yeah, I think, if you want to make the point that as you grow, as kids grow older, their height increases, that's a very good graph to show that. If you just want to treat them as 2 different categories, you probably want the left side, but you're more likely, when you're saying you're comparing 12-year-olds to 10-year-olds, to make the kind of like numerical comparison that 12-year-olds are older than 10-year-olds. So the bottom right graph may be more appropriate. So this is the kind of reasoning you have to put in when you want to decide which kind of graph is more appropriate. So here are some examples of this, right? So there's a pie chart out here, which is tells you what percentage of pie you've eaten versus what percentage of pie you haven't eaten. On the bottom left, there is something about, I think, the money in each one of these zones. The bottom two graphs are kind of interesting. If you look at the left, the bottom graph on the left side, it doesn't really give you the ordering that December comes after November as well as the graph on the right, which is basically showing an increase in the cost, for example, between November and December. But it does show you that the cost in December was more. So if you were trying to show the temporal nature, right, that there's some kind of seasonality to this cost increase, then the bottom right graph is better. But if you're just trying to show the differences, right, then maybe the bottom left graph is more important. So again, it's a question of what are you trying to communicate with this particular graph, even to yourself. Remember, you are your first client who you're trying to communicate with. There are other kinds of graphs. If you wanted to do correlations and trends, so this one is one of easy to eat versus tasty to eat fruit, which has seedless grapes in the upper right area, which I would kind of agree with is easy. And then on the bottom left is grapefruit, which is people don't think it's tasty, and it's kind of difficult to actually get the grapefruit out. Kind of like pomegranates. I hate. I love pomegranates to taste, but I actually hate how troublesome it is to get any of those things out of it.
Bananas is the easiest.
Bananas is not the easiest. You have to peel bananas.
Apple, you have to wash them and remove the stickers.
Okay, washing an apple versus peeling a banana. Let's have a quick vote. Everybody who thinks an apple is easier, say yes. All at the same time. 1, 2, 3.
No.
Yes.
Yes.
Okay, and everyone who thinks bananas is easier, say no.
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 Yes.
No.
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 Oh, I think there are more for bananas. Okay, Anusha, you win that one. We were having this argument earlier as to which what would people go with, apples versus bananas. I just eat the apple. Sometimes I don't wash them. Okay, all right. I should not have said that. So here's a good example of a very good scatter plot. This was done by John Snow. It was about the London cholera epidemic. So you'll see these little black squares everywhere on this plot. And these little black squares everywhere on this plot over here are houses in which people died. And if you notice all the houses in which people died, you'll see that they are kind of clustering very much towards the center of this graph. Now they're clustering towards the center of this graph because I presented the graph to you this way. But in the city, this is what he found. Then what he realized was that there was a water pump over there. And that water pump may be the cause of the cholera epidemic. So he had that water pump shut off. And sure enough, you had some of the cholera decreasing because of the water pump. It turned out it was contaminated with some animal waste at some point. And that's how the cholera epidemic spread in London. This was in the previous century. So this is a example of a trend graph. So there's a trend increasing from 1.5 to 5.5, but you can't really see it. You don't quite understand it. You think it may be a correlation. But if you want to show a trend, we'll just try and fit a line through the trend or fit a curve through the trend and put some error bars around it. If you want to show distributions, like how many things happened at a particular value, so this thing says count versus table, and it says at a value of around 57, there were 10,000 events happening. Then you'd use a histogram. But histograms also have their own trouble, and you need to be a little bit careful. You can't make the bin width too low. If you make the bin width too low, it will look like there are many, many peaks everywhere. If you make the bin width too high, it will look kind of more and more flattish. So you've got to be careful how you make your histograms as well. You want to make summaries of your data. It's always kind of nice to make summaries of your data. So this kind of plot over here is called a box plot. And a box plot has the center line at the mean value. The end of the boxes are the one standard deviation. So roughly speaking, within this box, 66% of the data is there. And you can see the data out here on the left of it. 66% of those dots seem to be within that box. And then 95% of the dots are within those two error bar kind of like things at the ends. And so this is what you want to summarize. And you're like, yay, boss, I did a very good summary of this, until you see this animation. So what I'm showing in this animation is that these are very different histograms of data. This data looks very different.
Hey
But the
Rahul,
box
we have a
plots are
question.
Yes.
Isn't the center line the median? This is from Mukunda.
Isn't the center line a median? It can be the median. It depends on what people plot in their box plots. Sometimes if they do the mean, sometimes they do the median. In this particular plot, to be honest, I would have to go and look at the paper as to what they used. Let me see if I can eyeball it. Can anybody eyeball it? Yeah, not really. It's kind of symmetric, right? It could be
Yeah,
the
when the
median.
data is changing, at the middle line, there seems to be somewhere the data is not there. I saw that, but no, there is one.
No, so this data is cooked up, right? This data is cooked up to have either the same mean or median. I don't, you're right. I don't, to be honest, I don't remember what it is off the top of my head. But we could just go and look it up after we finish, and we can get the answer over there. The point I want you to take away from this graph is that this summary is not kind of useful at telling you how different these distributions are. The first histogram is very different from this last one, right? Can you do better? Yes, you can. So here's some data. Here's
This
a
one
box
seems
plot
to
of data.
be
Yeah, go ahead.
symmetric. This one actually seems to be symmetric, and as we know, for symmetric data set, mean, median, modes are mostly same. So
Yeah, so that's why I don't want to. That's why I'm being very cagey about trying to even venture an answer for you. Mean median mode is the same, but I'm not sure what they are plotting in this. And I think Mukunda, you're absolutely right that people choose to plot different things. So this one is actually trying to make a slightly different point. And the slightly different point that this one is trying to make is, okay, here's the data on the left. I'm going to change the data distribution. Notice that the box plots remain the same. But the violin plots change because they are very sensitive to where the data is. So where you see when the data starts becoming less sort of uniformly distributed and more tightly distributed, the violins start looking like, you know, multiple violins rather than one violin. And so this kind of a plot, again, accessible in almost every language or every plotting software, is far more evocative of what the data is and a much better summary of the data than the box plot. Okay, so let's actually move to a hands-on exercise over here. And it's hands-on in the sense that I'm going to actually give you about 10 minutes. And I think maybe we won't do this in a breakout, and we'll do the last one in the breakout, just in the interests of time. Does that make sense, Anusha and Arya?
Yeah.
Yeah.
Should be fine.
Okay,
Yeah.
so the design exercise is this. So a whole bunch of kids went to a science camp. And this was the data they got out of it. That they asked the kids before they went to the camp, how excited were they about science? And 19 said they were excited. 25 said they were kind of interested. 40 of them said, okay. 5 of them said, not great. And 11 of them said, we are bored with science. So then they did it afterwards, after the camp. And from 19, it went to 38 excited. From 25, it went to 30 kind of interested. The people who were okay about it went down from 40 to 14. The people who were not great really didn't change much to 5 and 6. The people who were bored, it really didn't change much from 11 to 12. Okay, here's your job. Come up with multiple visualizations. In fact, come up with one visualization for this. Pen and paper only. So just use some pen, use a paper, come up with something, and then we'll have a bunch of you volunteer and show us what you came up with. Yeah? So 10 minutes, let's go ahead and do that. So this is a participatory activity. So if you want to get something out of it, just try something. Here's the data. Your visualizations don't have to be very accurate, okay? Just draw something. It could be a bar chart, it could be a pie chart, it could be anything you want it to be. It's coming to 8:15. We'll go back to that at 8:25. Okay, so I'll make a small interruption to our regularly scheduled program to tell you a little bit about the rest of the stuff we do. Let me see, how do I do that? I will stop sharing this for a quick second, and I'll share my entire desktop so you don't lose it. Okay, so here we are. Where is my Zoom? Share screen. Share desktop. I'm hoping you can still see this. Can
The
folks
slides,
still see
yeah.
it? Yeah?
Yeah, the slides, yeah.
Well, now you can't because of the way I've done it. We need to have this. Okay. So very quickly, let me tell you about our courses. So you can find out a lot of this on your own. So I'm not going to spend a lot of time by just typing Univ.AI into your browser, and then going off to the Programs tab. That's slightly bigger. And really, the only important thing to know right now is that we have both introductory courses as well as advanced courses. So the complete thing is called as Master Data Science and AI. That's the introductory plus the advanced. The introductory stuff is called the accelerated, which is the second thing you see out here, and the advanced stuff is the advanced stuff. And I won't even talk about that because you can go read about it. But what I wanted to talk about was this accelerated course over here. So I think I should probably click the details. And what it has is 4 courses. AI1, AI2, DSE1, and DSE2. And currently we are running them in that order. So AI1 starts on September 15th and it runs for about 6 weeks. Then AI2 takes over. And this one is about linear regression, logistic regression, all the way to multi-layer perceptrons. This one is mostly about convolutional networks, a little bit on autoencoders and GANs. In DSE1, we'll talk about visualization, SQL, all of these kind of nice skills, and also a lot of modeling, a whole bit of decision theory. And then DSE2 will go into more advanced machine learning models like ensembles, trees, in fact, all the various kinds of trees, random forests, and boosting, which, alongside the convolutional deep neural networks are the big models that people use. And then DSE1 will also teach you how to make a recommendation system, which is, kind of like a bread and butter thing you really ought to know. The course we just finished right now, very recently, is something called the Foundations course. And the Foundations course is over here, is the Foundations program. It actually has only one course, and that course is called Know This First, and it's kind of like a prep for the other courses. But it's, as I told you earlier, it's sort of interesting in itself because it takes you from not knowing any Python to writing a deep neural network library. This is what it looks like. Can you see is my browser visible?
Yep.
Yeah, so this, for example, is one example of our platform where we have a very nice system by which you can see the slides that you want, as well as look at all the data over here. Let me actually reload this at this point. Put it in some state. So this one just has a notebook. We're actually working on the ability to run it directly from the browser itself. So that's also actually kind of cool. But this is a very sort of like detailed piece of information on how to make good plots in Matplotlib. This one. The entire course looks something like this. Does the basics of Python, goes into functions, how to manage state and classes, goes into vector mathematics, developing code and testing code, goes into numerical Python, goes into statistics, goes specifically into maximum likelihood estimation in frequentist statistics, goes into gradient descent to train linear regression models. Gradient descent is the bread and butter of neural networks, and then goes towards neural networks on the way, talking a lot about the linear algebra and that kind of stuff in there. And this is kind of cool because It starts at the very, very basics. You have this sort of thing where you're getting started. You can pin this. And you can pin this as well. And you have notes. The notes and the slides and video all interact with each other. So you could be playing video. This little plus. And now I moved somewhere else. One of the most important things of a language is to be able to do computations which are symbolic, which are symbolic. So to assign variables to things and to do things. Okay. What I just wanted to show you is that it's very, very comprehensive. A lot of stuff for you. A lot of notes for each and every lecture. A lot of slides. All of these are available. You're taught how to use Git, and you're encouraged to go and get stuff on GitHub. You can get the slides yourself. Jupyter notebooks, and discussions on just about everything. So we have an entire discussion forum. You guys should join that discussion forum anyway by signing up for accounts at courses.univ.ai. And we do interesting things out there like discuss papers and all kinds of stuff. So I'll just show you. It's discourse.univ.ai. You'll get a follow-up email with all of this, so don't worry about remembering it.
Rahul, we have a question. After the person finishes the course, how long does he or she have access to this?
Forever. Why should you stop getting access to it? Right? So yeah, so this, for example, you have some questions over here, different categories, paper discussions, which we're going to just start up. And courses.univ.ai has the place where you can sign on. COUR, yeah, there you go. And I've already logged in, so it gives me a chance to go to my courses and my applications over here. But there'll be something over here if you're not logged on, which will let you log in. Okay, so I think I should stop. I don't have any more time to talk about that, so stop share. And shall we go to some ideas from people on where are my slides? There are my slides. But I'm not sharing it anymore, so that's not useful. Share screen, keynote, there we go.
Rahul, before you start, there's another question by Ashutosh. Can school kids with basic knowledge of Python and programming join the Foundations of AI course?
If you have basic knowledge of, so how about talk to me just afterwards? Because I do need to ascertain what your maths abilities are. If you have decent maths abilities and decent stats abilities, yes, but be prepared to work extremely hard. That's, by the way, generally true for any one of our courses. Be prepared to work extremely hard. It's one of these no pain, no gain type things. So be prepared for a bit of pain. I'm not trying to scare you away, but I don't want to lie either. There's work to be done, but if you do the work, you'll come out extremely good. That's my promise.
Just before we start, we have more questions, but we'll probably take them by the end of the session. So it'll be much better at that time.
Okay.
Yeah.
Satish has raised
That's for, yeah.
Yeah, okay. So we can take that later? Okay.
Yeah,
so,
we can take all the questions regarding the course at the end.
No, Satish is sharing his screen. He's sharing his paper graph. Can you bring it a bit closer? Okay, so that's it's as far as I understand, that is a vertical bar chart. And are you doing before and after next to each other?
Yep.
Yeah. So is it something like oh, let me put this into play mode so you can see it as well. Something like this on the bottom right.
Correct.
Okay,
yes.
Great. Other
and
idea.
One more. I have one more.
Go ahead.
Where I can say this is before. I just put some bubble graph. Okay.
So you're increasing the size of the bubbles, is it? Or decreasing the size of the bubbles before and after?
Yes. Before, I have two graphs, one before and one after.
One after. Oh, nice, nice. I hadn't even thought of this one. Very nice.
Thank you.
Anyone else? Please volunteer. No one else?
I tried to go with line graphs. So
go ahead. Yeah.
Is my video visible?
No, you're on orange screen at this particular moment.
Oh, okay.
But you can just describe it. That's fine.
Yeah, it's just line graph where where the time axis just has before and after, and basically to show how the values increased and decreased comparatively across, and the lines will be colored differently based on okay or kind of good or something like
Okay, so something like this then is what you're talking about, if I understand you correctly.
Yes, exactly. Yes.
Yeah. Super.
We have another person called Niran Sai who shared a file on the chat.
On the chat, let's go look
It's
at
basically pie charts.
Univ.AI.jpg. Click to download. Download. Okay, how do I see it? Click to open. Okay. Yeah, a pie charts. Yeah, lovely. So that's like this over here.
So
great. Anybody
another
else?
way is have a stacked scatter plot. So where you have on the x-axis you have before and after, and because the number of respondents are the same before and after, so you can actually see the movement of people in each category.
So
and
something
how,
like this?
yeah, something like that.
Okay. So yeah, this way you can see the before and after movement. Yeah, good one. I tried this. I didn't find this very useful for me. I mean, yeah, it just show the kind of like
Not that, the one on the left bottom.
the one on the left bottom. Yeah, I found the one on the left bottom kind of nice. Because I could straight away see that the red one decreased in size, right? Because the overall size was made the same because it was the same number of people. Yeah, great. This is great. Absolutely fabulous. So we have some various varieties over here. And by the way, you have a notebook by which you can produce all of these in Matplotlib yourself, if you're familiar with Matplotlib. Or you can actually learn it from those as well. Ooh, I'm trying to edit my... Can everybody see my screen?
Yeah.
A pie chart on it right now. Okay.
Yeah.
So this is the only one we didn't actually talk about. I'm actually really happy that one of you came up with the slope graph over here. By actually showing the increases, it becomes very clear. This in this slope graph, the only difference is that the one on the top actually adds up the excited and kind of interested to show the increase. This is the only one that people didn't come up with, which I thought actually is also somewhat useful. It's kind of like a difference bar chart. So instead of saying, you know, either before or after, I just plotted after minus before. And you can see that, you know, the OK went down big in a negative kind of, oh, Maitri, you made this one, super. Yeah, well, great. Do speak up next time though, please. Don't be scared of speaking up. We're all here to learn. Yeah, so there you go. Thank you. You can see that the OKs went down a huge amount and the exciteds and kind of interesteds went up. So all these are pretty good ones. One thing you might want to do is, especially if you're talking to your boss, you might
I have a doubt.
Yes, just one second. Let me complete this thought. So if you have, you know, you're taking the excited and you're taking the kind of interested, and 25 plus 19 is 44, and that becomes 68, you can make this kind of conclusion. After the pilot program, 68% of kids expressed interest in going towards science compared to 44% going into the program. So that's a kind of like a nice, you know, big text conclusion that you send to your boss. Yes, now tell me your doubt.
The graph which you're previously showing, yeah, this one. So if I'll talk about this graph, so in this graph, the information is not clearly properly visible to us, and I'm not able to predict that. I'm not able to say that is it the before or after part. So
it's not. It's the difference.
Yeah, so it's the
after minus before. So are you saying that I should have titled it better, after minus before, for example?
Yeah.
Yeah, okay, I absolutely agree with you. Yeah.
The percentage changes also make sense. Right? So maybe OK was very low before.
Pardon me?
Percentage changes, do they matter? Like initially it was this much, now it became this. So there's a percentage change.
Do you mind writing it on the chat? I was not quite able to catch you.
No, I mean, I just wanted to say that like initially say board was 10 and now it became 20, so it's a 100% increase. Or NOT gate was 5 and it became 1, so it's a 80% increase. So maybe some kind of percentage kind of.
Yeah, no, like percentages is dangerous over here, right? Because you don't actually have the denominator. Is that what you're saying? Is that we should put in the denominator as well? That's actually not a bad idea because it tells you how many increased, right? So you're basically saying new minus old divided by old.
Yeah, it's a relative increase over what was initially.
Totally. That's a good idea. Super. Okay, so in the last 5 minutes or so, let me just actually go towards do one or two like really fun exercises, then we'll stop at that particular point. So this is going back to the question of what kind of plot should you use for what. So there's this concept of something called perceptual effectiveness. And the concept of perceptual effectiveness is that what comparisons are good for what thing. So I'm going to ask you a bunch of questions and we're going to put up a poll, and please do participate in the poll and tell us what you find, okay? So how much longer is B compared to A? We'll run this poll for half a minute, so.
I believe it has to be in perceptions, right? Because there is no data over there.
Yeah, how much longer? Yeah, what multiple? Yeah. Sure. Shall we stop?
Yeah, stopping it now.
Yeah.
Okay. So.
There's no one voted?
So there's 4x and 3x have the greatest values, right?
Oh, I'm not able to see it. Right.
Yeah, so 4x and 3x have the greatest values. 42% of folks, 25 people said 4x and 27 people said 3x. Okay. So coming back here, I just find it hard to like switch between PowerPoint and this. Yeah, it's 4 times as long. Okay. Next one. How much steeper is the slope here? Go. Half a minute. Right, it's 20 seconds and we have only half of you who voted. Vote, vote, vote.
5 more seconds.
I will keep it a little bit longer. We'll keep it to 40 seconds to give people a chance. 5, 4, 3, 2, 1. Blast off. Okay. All right, so we have the winner for over here is 4x by 58%. And the next highest was 6x. Okay, let's see what it is. 4x, good. How much larger area? Start, go.
Ten more seconds left. Should I make it 40?
We have 50 of 67. Let's make it 35 seconds this time.
Okay.
5, 4, 3, 2, 1. Stop. Okay. So we have 51% think that the area of B is 4 times the area of A. To be honest, I picked that one too, but the answer is 10 times. So now you see your perceptual effectiveness, your perceptual kind of notion is starting to go wrong a little bit more. Okay, let's see the next, go to the next slide. How much darker is B compared to A? Let's go.
Five more seconds to go. And end.
Okay, so this one is fairly evenly divided between 2x and 3x, telling you that it's kind of hard to figure it out. Let me get my 2x is the answer. Now, last one of these. How much bigger is the yellow value compared to the green value? Okay, that's tough. So 50% chose 4 times, but there was a significant minority of people who chose 6 times, that's 20%, and 2 times, which is 22%. Telling you that it's a little bit hard to figure this one out. Okay, so you see some of these things over here. I think we're done with the slides, right? With the polls.
Yeah, we're done with it.
Okay. So the point in this exercise is that almost everybody got how much longer? And it was a tight distribution, around 4x. Quite a few people got the 4x here, but it was a distribution which is very weak in the sense that, lots of people said 6x and a lot of people said 2x. This one, very few people actually got the 10x part. This one, quite a few people got 2x, but quite a few people said 3 and 4 as well. This one, quite a few people got the 4x, but quite a few people said 6 times and 3 times as well. So what that's actually sort of like telling you is that your perception is more efficient in position on length than on slope and angle, than on area, than on intensity, and probably least efficient if I had started to use colors to say, oh, is red greater than blue? Or is red greater than green? Or stuff like that. So you want to use things like positions, lengths, slopes, and angles for quantitative stuff. For ordered stuff, you can use areas. So you don't care so much that this is 2 times that, but that it's bigger. Or that this intensity is like 3 times that exactly, but it's more. And then you have categories for which you should use color, right? Or shapes, which are different categories. So I'll just actually go over these 2 slides, exactly the same thing. And finally, let me just finish off in the last 2 minutes we have with the last thing which is kind of useful over here, which is that use color sensibly. And what do I mean by sensibly? If you're doing categories, right, don't use more than 5 or 8 colors at once. Otherwise, you're just going to make things very, very multicolored. And that's not kind of fun for anybody to see. If you have ordinal data, and what do I mean by ordinal data? I mean data which has values like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's not exact kind of values, but you're saying this is a 5-star hotel versus a 4-star hotel. Then use vary the luminance and saturation of your colors. If you have quantitative data, then you actually need to get some kind of quantitative color spectrum. And the one that's most often used is this thing called the rainbow spectrum. And it's these colors that go all the way across the rainbow. But this is actually terribly bad. Don't ever use a rainbow color map over here. It used to be the default color map, and I think it may still be the default color map in MATLAB. But it's a very bad one to use because your visual cortex perceives these differences in colors very differently. And that's actually shown to you in this plot A in the upper left corner. It's a very nonlinear perception of the changes from red to blue over here. So you think that you're going from red to yellow and you have a certain perception of how much things have changed, but actually your eye sees something very different. much better to use Weirdest, which is Matplotlib's built-in color map, which will actually do this thing correctly. And you can see it's in the upper left corner there, you can see it has a completely flat response to your eye. So if you go from the yellow to the blue on that, you go across the colors in a very sort of like simple fashion. There's a website called Color Brewer. Just go and type Color Brewer into Google, which will actually create different scales for you in just about everything. Just to get the nomenclature good, because I think that's probably an important thing. Qualitative scales are for things which are very different from each other. And they are typically used if you're plotting more than 5 things in a plot. These are the different things you'll use. Sequential scale is when something goes from 0 to 100, and it can be used for ordinals as well, as we talked about over here. But often it's used from stuff that goes from 0 to some maximum value, like a probability. Whereas a diverging scale goes from negative to positive. So here are 2 examples for you. On the upper right corner is a correlation matrix, again for the CARS data set. And there's miles per gallon versus miles per gallon. These are all the correlations over there. I think over here, red is the strongest correlation. No, actually blue is the strongest correlation and red is the weakest. And at the bottom, there is a sequential palette. Again, you can see how these plots were done in the notebook, accompanying notebooks. But this is a probability density. And so it is going from 0 to 1 is basically what it's plotting for you. So then, these are the 4 principles of effective visualizations. Have graphical integrity, keep it simple, use the right display, what kind of plot to use, and use colors strategically and sparingly, to be honest. Okay, so we're going to do this exercise, but we've actually kind of run out of time. So I'm going to leave it as a homework. We have an AMA on Slack, and Anusha will tell you a little bit more about that in about a second, and we'll actually run this exercise on that. You have 3 notebooks which have been given to you, which run straight on Colab. So the links are on Colab. You will not be able to edit them directly because otherwise you'll be munging ours, but you'll be able to make a copy on Google Colab and run stuff there. And then you can give us your answers. It's the answer essentially to a little bit of a mystery with these bacteria. And so let me stop over there. And actually, let me skip over the answer so that you don't get to see it, because that would take away the fun. And for further reading, look for Edward Tufte's books, really good. Look for Stephen Few's books, really good. And look for Alberto Cairo's books, really good. And he's come up with a new one. Okay, that's all I've got. Thank you, folks, and thank you for spending your Sunday evening with us. I'll let Anusha take over and tell you a little bit about where the notebooks are and about the AMA. And then I'm here for, conversation as long as you'd like.
Okay, thank you so much, Rahul. And I hope this session was helpful for you guys and also gave you a hint of what the sessions usually look like in our coursework. What we're going to do is we're going to send you a follow-up mail with the 3 Colab notebooks of what has been done in the lecture. One is the car where you saw the bar graphs. The second one is the bacteria, which you'll have to do it on your own, where you can definitely ask Rahul for further questions and us on the AMA channel. And the last one is the science one, if it was fun or if it was not interested, and basically the entire content will be given to you. Like Rahul said, you'll have to make a copy of it on your own personal Google Colab for you to edit it, because ours will be not editable. Arya has already shared the 3 links, the 3 different Google Colab notebooks on your chat. So you can take a look at those, but you will also be sent a mail with the same information again. Additionally, we'll be keeping an AMA channel open for the next 2 days, which is 48 hours, for you to ask any questions that you have about the course and also about the 3 notebooks that you're receiving now. And yeah, thank you so much for joining us today. And if you have any further questions, we are more than welcome to answer it now.
Yeah, feel free to ask away. There were some questions earlier, right?
Yeah, we had about 1 second. Let me just check the chat again. Yeah, that was Ashutosh's question about the school kids with basic knowledge of Python.
So Ashutosh, if you just want to talk to us offline, we can go into a little bit more detail about your background. There is nothing which says that you can be a school kid, you can be a programmer, you can be 80 years old. I've taught people ranging from programmers to librarians, to school kids, to artists. If you're willing to work a little bit, this stuff is actually not that terribly complicated. To get to a research level, you need to raise your game, but that's what we are here to help you.
Rahul, you have another question. Sorry, go ahead.
No, go ahead, go ahead.
Thanks, Rahul.
Yeah. Vivek Shukla is asking if all the sessions will be live or it will be a recording.
So the way it works is all the teaching sessions are live. There are additional pieces of information that we might want you to read before or look at before, and we would make video recordings of that. But the majority of the sessions are live and then recorded afterwards so that you can actually access them. And then what we do is we index them. I think I should give you a short, very, probably terribly too fast look at the platform. What we are then doing is with some lag, we're actually going to the videos. We are making the timestamps on the videos, and we are putting the timestamps to the exact places in the slides and the notebooks so that we can match those. So it's what we're trying to do is to try and make it possible for you to study these, in pieces. But so the long answer to that short question is that yes, most of it is live, but we will probably expect you to do some of it before you come to class and some of it after you come to class. So one thing we actually didn't show you in this particular part, because I was just going back and forth asking you questions, is that we also have little sessions, about 5-minute sessions, in which we break up the lecturing, so to speak, and make you go and do exercises, make you go and do quizzes. And those quizzes are relatively simple. There are no points for getting things wrong. You get things wrong and you still get full points. The point is that you actually have to attend them. And so, answering those questions again and again will help your recall of the subject. And we are implementing something we call Anki on the web. And Anki is this kind of, I don't know, you should check it out if you haven't already. It's an open source piece of software, ANKI, and it lets you have a bunch of flashcards. And you see those flashcards, and the program actually sequences how to ask you the questions and how, after a certain amount of time, it'll ask you the same questions again, just when you're about to forget stuff. And this is based on some real cognitive learning theory. Okay, there are some questions on the chat. Difference between master and accelerated plus foundation. So there's accelerated plus foundation is the basics, right? That's the kind of thing you need to know to be able to work anywhere in stuff involving at least convolutional neural networks. The master part builds on the accelerated, the foundations plus accelerated part, and does more advanced stuff. So it does a lot of natural language processing. And there are a whole bunch of electives you can take, some of which are more advanced statistics, some of which is reinforcement learning, some of which is generative models. You might have seen these examples of people doing dance transfer. So say I'm dancing, not very well. So you make a stick figure characterization of me, and then you take that stick figure characterization of me and you put it onto Anusha here. And so then she dances exactly the same way I'm dancing. That's a generative model in which you've taken the core essence of what dancing is, and you've transferred it from one person to other. So we teach you that kind of stuff. That's generative models. So that's one of the other advanced courses. So there's all kinds of interesting stuff. Look up on the website. I think Satvik is asking, what is the target audience for the advanced AI course? Well, you've got to know how to do convolutional networks. Either you do it with us, or you go and do like fast.ai or something else, or deeplearning.ai or something, and then come and do it. Yeah, so it's more advanced stuff. Satish Kumar is asking,
we have.
What's the visualization software?
I'll just go in order.
Yeah, I'm just kind of randomly picking. I would say Tableau Public is really good software, which is, a point and click, but it's always good to learn how to do, visualization in a language. So if you like R, ggplot's the way to go. If you like Python, matplotlib is generally the way to go. Okay, so let me see some of these other questions.
Just a quick point, in case your question is not answered on this chat, we'll definitely answer it in the AMA. So please don't worry that your questions are not being answered.
Yeah.
Because we've already gone over time. So we might have to end the
Anybody
session
who wants
soon.
to quit should feel free to go. And just join the AMA and ask more questions there. But if you have the time and want to hang on, I will answer the questions that have been answered here. So I think that was the difference between master and accelerated plus foundation. What next after the certificate course? Would this course, Mukunda, could you actually elaborate on your question a little bit? So which course do you mean aligned more? Are you talking about the accelerated course? Is Mukunda there? Or did we lose him? Might have lost him.
Please put it in the chat. The accelerated.
I think it might be the accelerated. Oh, you put it on chat. Okay. Would this course be aligned more towards getting a data scientist job? Yes, a data scientist, not just a data scientist, it's an ML scientist job. So I mean, you can divide data scientists into different parts, right? There's data analysts, there's machine learning people, there's deep learning people, and then there is more kind of like researchy type, advanced stuff, more kind of higher paid. Also like data learning engineers, more higher paid. So this will get you towards the this will get you towards the ML. It's sort of like entry ML scientist, deep learning scientist job. That's what the accelerator will take you towards. I would almost actually suggest that you at least do the natural language processing course from the advanced courses. Because that's kind of getting actually to be a very interesting and explosive field at this particular moment. So that next part will take you not only towards higher studies in AI and ML, but I would not necessarily think about this in terms of higher studies per se. It will get you to the top of the pecking order in your company, is what I'd like to say. Because these days, the kind of notion that research is only done at in universities is kind of wrong at this point. A lot of it is done in companies, and a lot of the more exciting stuff is done in companies, to be extremely honest with you. So let me give you an example from my own experience. I advised a bunch of my students who worked at TripAdvisor, and TripAdvisor came to us with the following problem that they wanted us to work on. They have like 8 different kind of characterizations of the reviews they have. Location of the hotel property or the bed and breakfast property, food, service. There are all these different characterizations, and generally there is some rating that people put on and some review that people put on, and you do some sentiment analysis and you say, oh, this review was good, or this review was bad. But what they wanted to know is this review was good about exactly what? Was it that this review was good about the service and bad about the location, or was it bad about the service and good about the location and stuff like that? And so my students and we just came up with a research plan. We worked with the stakeholders within TripAdvisor, and we worked together to actually come out with a very interesting scheme to be able to do this. And that very interesting scheme involved actually the combination of 3 different machine learning models, one of which was a Bayesian regularization-based model, one of which was a kind of clustering model called latent Dirichlet allocation, and one was a supervised learning-based sentiment analysis algorithm. So it involved combining 3 different algorithms together. And we didn't know that it would turn out that way at the beginning of it. And we have in our system these courses called capstone courses at Univ.AI, where we're using our connections in industry to basically place you in a company for a while on a problem that is relatively well contained, like that TripAdvisor problem. It's not this like infinitely huge research problem. And so the idea is that you go in there, you work with us as professors, and you work with them as advisors, and you come up and you produce some value for them. So it's like a super up internship, right? But you're sort of like, you know, talking to professors as well as the people within the company. So I hope that answers Mukunda your question. If not, just, you know, put some question up over there. Yeah, some of the slides will definitely be shared. When we'll do that in a little bit. I have to sort of like compile it to do that part. But the links are already shared on the chat, and we'll share them over email and on the Slacks that we create. Okay. Just curious, in the website's FAQ, a degree plan for the future is mentioned. How far is that? Still quite far. I don't count on it right now, to be very honest. It's going to be a while away. Is certification paid? I'm not sure I actually understand that question. So maybe we can talk offline, and or you can ask a little bit more around it, and then I can answer that. Who are the targeted audience for the Advanced AI course? People who want to get, you know, to be really good at this stuff. What is the visualization software? Tableau Public, Matplotlib, and ggplot. Then Harshita is asking, do we have to choose between DSE and AI right from the beginning, or could we choose after a few modules? You can totally choose after a few modules. You don't have to choose right at the beginning at all. Ravi Bansal, isn't Plotly better than Matplotlib? Depends on what you want to do. If you want to do dashboards, yes. The nice thing about Plotly, I'll tell you, is that it actually has a Matplotlib compatible API, so you don't have to choose between one and the other. So you could use Plotly by using the Matplotlib code. From Anup Gupta, what is there for the master student who is currently pursuing research in CV in computer vision and deep learning? Definitely you want to go off directly to the advanced courses. They're not running right off the bat, but come and talk to us. We can actually probably give you some really kind of interesting research stuff to pursue if you want to do that. From Nakul Havaldar to everyone, how will faculty help me in master's application? Do you mean for application to various master's programs? The answer to that is, well, if you've done well in the courses and you've impressed us, we'll give you good recommendations. We'll help you also in writing your some of your statements and so on and so forth. One of the things, by the way, which is really not mentioned on the website, but it may actually be useful to some people, is that we also, during the course of these various courses, conduct workshops in writing and communication. So, you know, things like how to use active voice. You should mostly use active voice. Don't use passive voice much. When should you use passive voice? These kind of things to communicate your stuff. So that's sort of in the direction of answering Nakul's question. For Anil, do we get the link for AMA in the mail? Anusha, do they get it in the email?
Yes.
Yeah.
So they'll be sent out an email with all of this. Also, additionally, some of the questions regarding the courses have also been answered by Siddharth in one of our previous EMAs, which he had done. So I've just shared the link on the chat, but again, it'll be sent via mail also.
Okay. Then
and there's also a Telegram link sent. So, and there is a WhatsApp number, which is also shared by Siddharth on the chat.
So I'm getting confused. Which one should we?
So for now, you can basically join any one of them, and we'll answer your questions on all of them. That's the idea, basically.
Okay.
So
all right.
We kept all the channels open for you guys.
Then Rutuja is asking, can I directly jump to AI2 if you have the needed prerequisites? The answer is yes. We haven't actually put that information on the website. That's going to come up. Siddharth, are you on? Is Siddharth on? I guess not. That's going to come up, I think, on Monday or Tuesday. So you may want to check in at that point. Yes, but you can totally jump to it.
Rahul, sorry, I was on mute.
Oh, so the question was, can she directly jump to AI2 if she has the needed prerequisites? I said yes. And I believe the information is coming on Monday or Tuesday on the website.
No, it's already on the website. So you
it's already on the website. Okay.
Yeah,
so
you can go to apply, and there's no, I mean, all the programs have tests associated with them, which you need to take to apply. But if you want to take just a course, at this point, only AI and AI 1 and 2 are offered. So
okay.
You can pay for it and enroll. So there's no barrier to entry there.
But do talk to us before you enroll in AI2, so that we can make sure you have the right the right background for it. I think Mukunda's was a comment on that. Where is the link to join AMA? Coming in the email. So Satvik is clarifying his question. I actually meant, would an ML engineer with say 5 to 6 months experience need to do this course? Which course do you mean, Satvik? The accelerated one or?
It's the advanced AI course.
The AI too?
Satvik, you're the same Satvik, right? IIT Madras?
Yeah.
Okay, we know you. Don't worry.
Okay. Would an ML engineer with say 5 to 6 months experience need to do AI too?
No, it's the advanced AI course that AI 3, 4, 5, those courses.
I would say yes. I mean, there are research projects you can do without going to those courses. Absolutely. But if you really want to get into what's exciting right now, right? You want to do the advanced courses.
But also, Rahul, since there's a while before we offer the advanced courses, Satvik, stay in touch. Like I've told you in the past, there's stuff coming up. We are starting research. We'll probably be starting January offering project work. And so, which might happen before the advanced course happens. So you'll have lots of options. Yeah.
Yeah. The kind of options might look a little bit confusing right now, but then that's kind of like the nature of the thing. We want to be doing exciting stuff fast, so to speak. Okay.
Question for Naku, I think. Okay, we'll. Yeah, you're going in sequence.
Register somewhere to get the link. I think Miloni, you must have registered to get into this thing, right? So you will get if they shook you down for your email at that point, you will get the links.
Yeah. Anyway, just everyone who has Telegram, go ahead and join the Telegram link that I just gave you. It's a group. The WhatsApp number, note it, 701-900-5704. We don't have a group there, but that's for one-on-one question answer. Usually one of us will get onto your questions and answer them. Favor requested when you do send a message, introduce yourself. Otherwise, most messages we get are hello, and I don't know what to do with a hello, right? So it'd be nice. Just introduce yourself, tell us your questions. If since you attended this, you probably have precise questions. So write that down. One of us can even get on the phone and talk to you, right? So all that is available. Yes, website is Univ.AI. On my monitor, on my ISP have a problem. I have to type in www.univ.ai. So if for any reason, if you have a problem, type the preceding www.
Okay, so there are some other questions. Vikesh Kaul, in terms of curriculum comparison with Harvard's Masters in Data Science, what are the things that are additional or missing? Okay, so the AI1, AI2, DS1, and DS2 essentially follows to some degree. Some things that are done in the Harvard one are not done here, and some things that are done here are not done in the Harvard thing. I'm hoping it's better than the Harvard thing because I was involved in the Harvard thing, and so this is sort of my second chance at doing it. So it replaces CS109A and CS109B, AI1, AI2, DS1, and DS2. So that's the comparison there. What about the rest of the curriculum? A lot of the advanced courses have one-to-one comparisons. Like for example, there's a reinforcement learning course over there, which is available here. There's a generative models course. Actually, right now the generative models course is not available over there, but there's typically an advanced deep learning course available in which some of the generative model stuff is done over there. So there's, for example, actually I taught that AM207 at Harvard, which is the Bayesian statistics and generative modeling course. That's there as part of the statistics part of the curriculum in the advanced courses. So if you do some of the advanced courses and the 4 basics, it's pretty much, I would say, compatible. There are some things that we will initially probably miss until we become bigger. So, for example, there's a good course in reinforcement learning in medical sciences by Professor Finali Doshi at Harvard. We won't have that right now because we have to. We're not as big as Harvard, to be honest. So that's what you will find missing. And in terms of what you'll find additional, I think it's more on the sort of like topic oriented things. And Harvard does not have a generative modeling course right now, which we do. Okay, so what else? Anup's question. I'm a master's student from IIT Indore and I'm pursuing research. If I want to reach you, how can you do so? You can contact us on any one of those links. Also, if you want to email me, I'm Rahul Dave, RAHULDAVE. Let me actually share that up on here to everyone.
No, Rahul, don't do that.
Why not?
Let's go through a central point of contact.
Okay, so they'll route it to me. Okay, fair enough. Fair enough. And I'll be on the Slack, so you can also get me on that. There is no different masters in AI and DSC on the web now. It's been combined now, I guess. It's been combined?
Yes. Yeah, we have a single program where you choose to specialize in AI or data science engineering halfway through the
but
course.
nothing's
question you answered earlier, right?
Nothing's really changed, right? I mean, it's the same thing. It's the
Yeah,
same.
earlier you'd have picked one track before the other. Lots of questions started about which one to pick. We said, okay, really, you don't have to do the picking until 6 months in. So just do the same thing.
So I think this answers two questions at the same time, actually. The website is Univ.AI, right? Yes, absolutely. But as Siddharth said, you might have to put the www in front of it. How many students in one course at a time? So the answer to that is a little bit complicated. It actually depends on how many teaching assistants we hire. So we cap it at the teaching assistant level because we don't want one teaching assistant to be dedicated to more than between 15 and 20 students. This is comparable to all the best universities, and any more than that, and it's not a good scene for the students. So you want to keep it on the lower side, and so that's where our cap is. So that's it, Nakul. That's a somewhat complicated answer to your question, but the cap depends upon the teaching assistants we are kind of hiring. Okay. The link to the Slack channel.
It'll be shared via mail.
Yeah.
Okay, it'll be shared via email.
However, if you do have Telegram, please join the Telegram group. That's also a permanent group. So
the Slack channel, I think the fun thing is that we're going to have AMAs on it. Maybe Anusha, you can just talk about a sentence about it.
Yeah, so basically we're keeping these AMAs for you to first definitely ask about the Google Colab notebooks that you'll be getting tonight. So since we have not run them, we want you to actually go back and actually do those notebooks. And if you have any questions, you're more than welcome to actually ask questions about
the one which is called bacteria.
Yeah.
Because we discover something about this data which was not discovered by people for about 40 years.
Yeah.
And I'll only share the slides, the appropriate slides after it, because otherwise I'm going to give away the answer to that, which I don't want to do.
Yeah.
So let's take about 5 days to do that, or something like that. Maybe 4 days. 5 days is too much. Let's take until Thursday evening, and then we can go from there.
Okay. Yeah. Apart from that, the AMA is just for you to ask any question about the course. So Rahul will be there, Siddharth will be there, all of us, the teaching assistants will be there. So you're more than welcome to ask us questions over it. Scholarship details. Rahul, Siddharth, do anyone of you want to take this question?
Complete an application, and depending on your application and interview, we take a decision about your eligibility. Also depends on whether you're a student or whether you're a working professional. So lots of things go into a scholarship decision, right? Primarily biased towards a combination of what your incoming skill is, and also how much financial assistance you do need. As you'll probably notice, for the quality of education that you get and what you pay, that's pretty much close to free. So
Siddharth, are you talking about the other
no, I'm saying just any of our programs compared to the inherent costs of offering them, they're more or less free for the students. So in a manner of speaking, right? So I think our scholarships go to those who are unable to afford them and or are extremely good, right? So that's kind of the more or less guiding criterion for awarding a scholarship. So I'd say apply, take the test. One of us will talk to you and we'll take a decision.
Okay, so if there aren't any more questions, it's late. Let's split and let's meet on Slack. Oh, and one more thing, Anusha, the AMAs will be the AMA Slack channel will be also used in the future for more AMA type conversations, right?
Yeah, definitely. Yeah. We're basically creating a community on Slack so that any AMAs that happen in the future, we're considering getting AMAs from researchers and different people who are working in the AI field. So we'll be adding you to that community as well. So the idea is to create a community for AI.
So yeah, so do that. Join up. I'll type it here and we'll send it in the email as well. Join up at courses.univ.ai, even if you are not planning to take any course with us. And also join up the discussion at discourse.univ.ai. If I can spell it right while sending it to you, that is. Here you go. We'll put that on the email as well.
Harshita, you raised your hand. Harshita? Harshita, if you're not able to unmute yourself, or if there's some issue, you can probably type in the chat, maybe. Okay, just a general information, you'll probably get the email by tonight or by latest tomorrow morning with all the links all together. So we have a list of things to give you out. And yeah, if you have any further questions, we can talk for another 2 minutes or let's split.
Thank you, everybody. I'll stop sharing my screen now.
Okay, shall we split?
Yeah, let's split.
Okay.
Thanks, everybody.
Thank you so much.
Everyone. Yeah.